Welcome to Brain Vision.
In this problem, water is discharged from a nozzle with a given velocity and strikes a blade mounted on the cart. We want to determine the tension developed in the cord which is holding the cart stationary and the normal reaction of the wheels on the cart. Now, before we can apply the steady flow equation, we need to find the mass flow rate at A and then at B. So the mass flow rate at A and B is dm dt. And dm dt is equal to the density of water, rho W, times the volume flow rate Q. So this is the density of water, rho, times the cross-sectional area of the nozzle A, times the speed V. And so this is 1000, the density of water, times the area, which is pi r squared, or pi over 4, times diameter squared, 0.05 squared, times the velocity of 12 meters per second. And so we get the mass flow rate to be 7.5 times pi kg per second. Now that we have the mass flow rate, we can refer to the free body diagram and we can calculate the components of the force acting on the cart, Fx and Fy. So if we take the right direction as positive and look at the horizontal components, the sum of all the forces acting on the x direction is equal to, using our flow equation, this is dm dt multiplied by vbx minus vax. And so the only force in the x direction is the x component of the force due to the water. So minus fx is equal to dm dt, which is 7.5 pi into the x component of this velocity at b is 12 times the cos of 45 degrees, the cosine, 12 cosine 45 degrees minus 12 at A, it's purely horizontal. And so the x component of this force Fx is equal to 82.81 newtons. Now the y component, taking the upward direction as positive and applying the same equation, the sum of all the forces in the y direction must equal dm dt times the y component of Vb minus the y component of the velocity of the water at A. And so this force is Fy, and Fy is equal to the mdt, which is 7.5 times pi into 12 times sine 45 degrees. That's the y component of the velocity of water at B, and there is no y component at A, so that's 0. And so the force has a y component of 199.93 newtons. Now, using the results for Fx and Fy and referring back to our free body diagram, we know that the sum of the forces along the x direction must equal to 0. And so 82.81 minus the tension T in the horizontal direction must equal to 0. And so the tension in the cord to keep the cart stationary, T, must equal to 82.8 newtons. Similarly, from the vertical components, the sum of the forces in the y direction must equal to 0. And so the normal force minus the weight of the cart, which is 20, times 9.81, minus the y component of the force F, 199.93, must also equal to 0. And so the normal force acting on the wheels of the cart, N, is equal to 396 newtons.